Welcome back to the Roll Up. For today's podcast, we were joined by Alexander from Catalyst to discuss the state of the interoperability landscape. We talked about the idea behind unit of liquidity, the n-squared problem, the idea of cross-chain intents, as well as Catalyst's mainnet deployments on the Optimism stack. We are big fans of what the team at Catalyst is doing and had an enjoyable technical podcast with Alexander today. Hope you enjoyed, and a quick word from our sponsors before we jump right in.
Welcome aboard on our journey into the singularity. This is the endgame roadmap for Frax and Fraxtal, the new L2 out of the Frax ecosystem that is totally based on fractal scaling. Fraxtal is a modular L2 blockchain built by Frax with modular and fractal scaling in mind. Fractal scaling is based on the Mandelbrot set of fractal images, and it explains how L2s become L3s and the entire app chain lifecycle goes through its evolution. The Frax ecosystem is made of some of the top builders in the space and has stemmed from its OG days of the Frax stablecoin. It is now in the LST space, the LRT space, and this Fraxtal L2 joins the existing suite of Frax products, including Frax Swap and Frax Lend. You can see Frax Ferry, the bridge to go from any chain, Arbitrum, Optimism, or mainnet into the Fraxtal mainnet, bridge your tokens, and bring your Frax assets into the Fraxtal ecosystem. Join today to get the best out of Fraxtal. You are still early. Join today, take part in our expedition into the singularity.
Everclear is pioneering the clearing layer. The clearing layer can almost be thought of as splitwise when you go on a trip with friends, but for the blockchain. What I mean by that is when users are sending cross-chain messages, there's oftentimes fillers and solvers who have balances left on different chains that they need to rebalance and reset their positions. This is where Everclear comes in. Everclear is pioneering a collaborative approach to the chain abstraction future, and they are willing to work with interoperability partners, solvers, and other providers in the space to build a interoperable and chain abstraction future. Please check out Everclear at everclear.org, and welcome back to the Roll Up.
Welcome back to the Roll Up. Today we have an interesting podcast with Alexander, the CTO of Catalyst. Catalyst, self-described as the modular liquidity engine, solving one of the problems that Rob and I just continue to come back to on the roll-up, which is like we're trying to figure out how we get thousands of app chains and all these different chains, but then how do we put these chains together and actually give users an experience that is unified and kind of similar to that of an integrated chain. So, Alex, you've written quite a few papers, or maybe one main one about the unit of liquidity, which kind of derived, or from there, Catalyst has derived. So would love to welcome you on. And yeah, would love to learn more about your background in writing math papers. I think Robbie is gonna have a smile on his face.
Yeah. So my name is Alexander. I'm the CTO of Catalyst. I'm the main guy behind the technical design of Catalyst. And one of the authors of our Unit of Liquidity white paper. I can jump right into the white paper. So the idea is essentially you need a way to do make a cross-chain AMM that is very usable for users. We've seen how Uniswap v2 and Balancer and even Curve has kind of taken off and established themselves as the way for long-tail assets to be exchanged between each other. And I wanted to replicate that experience with cross-chain. There's a lot of different approaches to do it. And I wanted one that was scalable cross-chain, since I love the cross-chain ecosystem and I want it to be everywhere. And I when I initially created it, I saw the world moving towards a cross-chain future with a lot of applications moving to their own chain. And for that, you kind of need something which is a natively cross-chain. And that was the idea behind designing the unit of liquidity for cross-chain MM.
Yeah. I keep coming back to this as like the extensibility problem of of crypto. Like we have all these chains again, and we have to figure out a way to combine them all. But like a lot of these interoperability providers aren't meant to just be, having their service easily adaptable and permissionlessly deployed across many chains. And I think that the solutions which can will kind of end up pushing the envelope for where the general modular ecosystem grows, and kind of how we get to the next kind of step. So I guess you're talking about asynchronously swapping assets between different pools on different chains. And like I'm curious kind of how we got here from your perspective, and kind of why you think that this is a very important use case to build out for the space.
Yeah, so I don't even know where to start because there's a lot of issues when you initially want to do this. I think the most specific issue you have is the n squared issue, where if you want to synchronize state between chains, you need to have the state of all other chains on the local chain that you're interacting with. And as you get more and more chains, you need to have more and more states. You actually need to have n minus one on your state. You need to have the state of every other chain except yourself. But you also have yourself, but that's trivial. And then on every single chain that you have, that's the n chains, you need to have your information as well. So that means that you have n times n minus one amount of shared states, and that is, when we grow, completely unhandleable. So you need to figure out a way where you can get rid of this problem. Essentially, you want to divide by n, so it's only n and it scales linearly with the number of chains. And that's the idea behind asynchronously doing these swaps, because now you just send enough information over to compute the remainder of the swap, and that allows you to scale linearly with the number of chains rather than scaling quadratically, which is significantly better. Even at 10 chains, the liquidity efficiency or efficiency of the system in general is 10 times of a comparable solution, which is significant. And if you have even more chains, imagine you have 20 or 100, you're essentially 20 or 100 times better than the competitor.
Yeah, and scales from there. The complexity scales exponentially from there. And so, is this problem currently faced by, like, do bridges in their current design face this complexity problem where they're trying to combine state from multiple different blockchains? Are like, who is currently faced by this complexity problem trying to extend to multiple different chains?
So any protocol that want to interact cross-chain essentially have this issue, because if you want to have your app natively access all of the storage, this is kind of the way to go. There's a lot of ways you can optimize this. Stargate V1 used the Delta algorithm to try to optimize the number of messages has to be synced, but they still have the issue where they need to allocate liquidity for each pair to the other chains, and thus suffers this liquidity offset. There's a lot of other solutions that if you just naively try to scale them, then they would suffer from this issue. This at some point, someone, I can't recall who, but they imagine this DMM, a distributed MM, where they try to circumvent this by just taking the edge of the MM curve and then sending it to other chains. However, the issue with that is that you get 10 times or whatever number of chains you have, the amount of impermanent loss, which is not suitable for most users. Bridges specifically do not have this issue, or may have it depending on the integration. If you have a native integration like Layer Zero's specific cross-chain tokens, then you don't have these issues because Layer Zero owns the token every single chain and don't have to duplicate it. But if you imagine a system of kind of fragmented implementations that might be Optimism with the Optimism bridge, maybe the native USDC transfer, maybe some Layer Zero or Wormhole bridge coins as well, then you begin to get this issue as well, but even more significant. But now if you're going to go between, say, Base and Optimism, which coin do you go between? And imagine that you have 10 chains like this with a native bridge. You have the specific AMB bridges that we're familiar with. Then now you have this problem for each bridge, but you also have it between the bridges. So it's not even just the quadratic problem. It becomes even worse than that.
Yeah, and I think we're seeing some other projects in the space try to attempt a similar solution. Similar to, like you mentioned, Layer Zero deals with complexity by sort of netting out the different OFT tokens that move cross-chain. We've seen Everclear now go and be a clearing layer that is able to net out the inflows and outflows between different chains. Now, something like that is still somewhat reliant on a bridge. Catalyst is very different. Could you explain, like, kind of like the solution space that is out there to solve this problem now, and then how you guys are fundamentally solving this with a different type of solution?
Yeah, there's many approaches to solving these, and I don't want to discount one and say Catalyst is the best one. I think they're complementary in many ways. The XEC20 model, for example, is just one where you aggregate different competing protocols. The centralized blockchain, where you kind of go to as a hub, is also a solution. But specifically, the hub has the disadvantage of you wanting to, defragment by creating more fragmentation, which kind of like goes against what you want to try to solve. But so those are like the two major ones, like concentrating in a standardized way, and then just creating another layer that you can send to and send from. I think the obvious disadvantages are of the fragmentation that Catalyst doesn't inherently have. Our solution is instead to aggregate as many things as possible into one. And without going too much into details, we have a feature called generalized incentives, which is essentially able to wrap different messaging protocols so that we can support one or more in a single space. And that allows us essentially to get to every single chain and then use Union of Liquidity to bridge optimally, or like not bridge, but swap optimally between the different chains.
Gotcha. And so, like, how is Catalyst then able to not like suffer, I suppose, or not be prey to the limitations of the underlying interoperability providers? Whom, let's say that there's 10 new chains that have launched this week. How is Catalyst able to be more extensible, but the interoperability providers which Catalyst uses are slower and more kind of like ossified in the sense of like where they operate based on their own validator sets or kind of security parameters, things like this?
So there's essentially two parts to this. One is that we want to try to get as many messaging protocols onboarded because each messaging protocol has a specific advantage. This could also be kind of bridge types. So in certain ecosystems, with these rollups as a service or chains as a service, you essentially would have a layer that can send messages between, and then Catalyst will be able to solve that through integration with generalized incentives. So now that is supported just kind of right out of the box. And then the idea comes that we believe that these chains will be supported by different messaging protocols, and just supporting all of them will get us to all of these chains. So of course, there's still the like first step to that chain that has to be overcome. But once that is done, as long as generalized incentive supports it, which at some point it hopefully will support every single messaging protocols, we will also be able to get there. And once it's connected at that point, then now it's connected to the whole rest of the Catalyst network, where you can go between different messaging protocols since they're standardized between generalized incentives. So even if they're in different messaging protocols and different ecosystems, you can get there through generalized incentives, which is the integration layer of Catalyst.
Got it. I think it's something important for listeners to understand, because this is what was a fundamental difference in my mind when I first learned about Catalyst, was that there's no bridging. And so it's important to separate the interoperability process into two pieces. You have these general messaging layers, and then you have a bridge piece on top. And so Catalyst still uses that general message passing layer, but it doesn't use the bridge part on top. And so there is no asset that is being transferred across chain, right? It's simply a swap that takes place by sending the asset on one chain and then receiving the asset on another chain. And so this is like a cross-chain liquidity pool functionality and not a bridge that sends something across these chains. So when you're like thinking about this new type of mechanism to deliver value, between different rollups and different chains. Like, what was it in your mind that was like, no, let's get rid of this bridge asset transfer layer altogether, and let's still use the general message passing layer, but let's build something different on top of it?
So Catalyst, or the idea about Catalyst, is from the era of all of the bridge hacks, which I'm sure you're familiar with. They're kind of also still ongoing. So it's still a huge issue that a bridge is essentially a custodian. So you send them assets and then you trust them to hold them. And then you give your assets on the other side, often through IOUs. And then you will hope that they get the assets back. And I saw all of the hacks. You think, and I was like, this is not the solution. And then I also saw that to go cross chain, you would swap into an immediate token, bridge to the other side, and then swap out to the other side. So if you wanted to bridge a token that was not ordinarily bridged, often it will consist of going to an intermediate token and going back to the token you actually want. And I just thought this can be done better, and I wanted to get rid of that. And then why then still use something that's still bounded by this? And that's because we have one specific advantage that a custodian solution doesn't have, and that is we have smart contracts where the logic can still verify through. It means that we can set limits on what the messaging protocols are allowed to do and how they interact with us. So right now on the contract on main and Catalyst, a bridge couldn't log us by more than 50%. Once that limit is hit, the protocol deactivates, at least for a certain period of time, and then it will activate in the future. And in this period, people will be able to withdraw their funds. This wouldn't be possible with a custodian solution, because they have the keys to that specific logic they have. And this is why I think having an application doing this rather than the bridge itself has significant advantages. Specifically, this is very advantageous when you have a solution where it's not a smart chain you're communicating with, where we would still be able to do this through messaging, but bridging might not be able to reach those or secure those chains through on-chain logic.
Very cool. And so to really hone in on this idea of unit of liquidity, if we think about an AMM, right? Because it's important to think about an AMM, not a bridge. So thinking about AMMs, take an AMM on Uniswap, just on Ethereum mainnet. ETH, right? ETH USDC also depends on ETH wrap Bitcoin. The price of ETH on this AMM depends on all of these different pools that the asset is part of, right? And so and that is a growing complexity problem, because then you have to get the state of the pools of all of the pools that this asset is in. Now, how are you able to scope down the state of the liquidity pool so that you don't have to consider? You mentioned that you're not considering the state of all of the blockchain on all the blockchains that you are tapped into. How are you able to reduce the state that you have to manage in these different blockchains?
So this trick is essentially facilitated through the unit of liquidity. We can run a very simple example. Let's imagine we have a pool of two chains. So we have two vaults, one of each chain, and we have 100 tokens on one side and 200 on the other side. When you go to one of these pools, you would select the asset that you want to go through, and then we get the local state on one side. We know there's 100 tokens on the chain, and when you now add no more tokens, let's for simplicity say that you add 100 more, then now we calculate the fraction between what you're adding and the future states. So the specific calculation we do is 100 divided by 100, that's the asset right now in, plus 100, that's the token you added. So you get a half out, and now we translate this. This is not the exact numbers we're running, but it's very, very close. Essentially saying you get 50 units equal to 50%. We take these 50% and go to the other side, and now we take 50% of 200, and you get 100 assets out. And if you do this again, you see 100 divided by 200 plus 100 is roughly a third, and a third of 100 is 33. So you see that the swap you just did had the same impact on the swap that you would have in an AMM. And actually, if you take these two equations and put them together, you get the Uniswap V2 equation. The specific Catalyst logic is slightly more complicated than that, but that's to facilitate weights. So you can say I want to distribute liquidity on different chains like this, similar you could in Balancer, or you could change it to be more of an amplified one, so you can swap stable coins, similar to what you can do in Curve.
Makes sense.
Yeah. How closely related is this concept of cross-chain liquidity providers with solvers in this intent world where we have solvers that are filling intents to go cross-chain and they have to hold assets on different chains? In this liquidity model where we have one side of the pool on one chain and we have another side of the liquidity pool on another chain, it's almost like we're creating this like asset topography across different chains, and users can submit their intents to go and get filled by a certain liquidity provider. Is it very similar concepts? Maybe, what is the similarities? What are some of the differences?
I really like the way you described it. You can essentially, look at Catalyst as being kind of liquidity pot sitting around. All of Catalyst liquidity is accessible on chain. So if you have a vault that has 2 tokens on one side, you can do a normal swap in that between the 2 tokens. Just as you could if that liquidity was in a Balancer, Uniswap, or Curve pool. You can do the same thing in Catalyst. But there's an additional feature of Catalyst is that we have 2 participants in the system that's off-chain. We have the relayers, which are facilitating sending the swaps across. And then we have something we call underwriters. Underwriters are essentially able to take liquidity from the destination pool or the destination vault and use it for their own purpose. So you can imagine that some tokens goes in on the one side, and a meshing protocol will take some time to generate a proof. This to make sure it won't reorg, it will be finalized, and all of the security. And on the other side, immediately, an underwriter comes and says, I want to extract these tokens and give them to the user. And then when these tokens arrive to me, then I will claim them. This essentially allows the swap to happen instantly, but it can also have the advantage that it can be used to fill intents. So if you have an intent describing the route, the same solver can actually go and see, okay, Catalyst has liquidity for this route, and do that swap instantly without suffering any price change, and now fill the intent without holding any tokens at any point. And that's a significant improvement to how to complete the liquidity between different chains using Catalyst and like this kind of asynchronous liquidity on all the different chains.
At risk of like torturing this analogy, it sounds like almost like a flash loan. Like I can like borrow liquidity from Catalyst, go use the liquidity to fill an intent, and then with the liquidity that I get for filling that intent, I can go repay the Catalyst liquidity pool.
Yeah, it's slightly more complicated than that, of course. But yeah, in like the grand scheme of things, that's totally possible. And that's one of the things. That's why we call Catalyst Liquidity Engine. We want to facilitate these cross-chain, all of these cross-chain use cases that you can do cross-chain. If there's intent, if there's a protocol that you're building, if there's logic, we want Catalyst to be able to fill all of it. We have specifically actually built something we call liquidity or like logic-dependent swaps that really helps this. If you want to do something on the destination side, you can say that your swap is dependent on that execution. So this could be filling the intent. If you are not the fastest and you didn't manage to fill that intent, you can make it explicitly fail. And this helps, combine the liquidity. Even though it seems kind of fragmented between all the chains, this helps to like combine it so applications can use this almost atomically between the different chains. So I really like the analogy. I don't think you're killing it. I think you are spot on.
Yeah, and if we bring it to kind of what is now live on Catalyst on mainnet with the super chain, kind of the OP stack chains, maybe you could talk us through how this works under the hood from the liquidity pool perspective, as well as the involvement of any logic dependent swaps or any kind of intense or Catalyst's solver network as well.
Yep. So we have a deployment on mainnet right now with 3 chains. We're not allowed to call them super chains, but they are OP stack. And it's Blast, OP, and Base. Hope I recall correctly. We're very embarrassing with it. Then it's using amplified vaults to essentially swap ETH between them, so you can bridge your ETH in like 12 seconds or 30 seconds by getting them underwritten. And how it works is we have a router you swap through, and then on the other side we have another router that will then handle your swap, so you can get it wrapped and unwrapped. And very simply, we use the logic-dependent swaps to say to the wrapper, if the unwrapping fails, don't do it, but that will always succeed. But in the future, you could imagine that you want to swap from, let's say, Blast to OP, the token, not the gas token. And if the swap between the ETH on Optimism to the OP token failed, you could revert back to get your ETH and Blast back, because now you didn't want to go through with this. So that's a future application of this logic-dependent swaps that we're very excited to see. This works wonders for both aggregators implementing us. They can choose, what do we want to happen if we can't get the assets that the user wants. And it also works really well in the future when we do kind of chain abstraction. If you want to purchase an NFT of another chain, but it got bought, what do you want to do with the tokens now? Do you want to get them on the origin chain, or do you want to get them as like a fallback on the destination chain? Furthermore, we have the two off-chain services. We have the relayer running. So we're currently using Wormhole. So that's a relayer working to get these Wormhole proofs, which are signed messages by the guardians, and then submitting it on chain. And then the swap goes through. And we have underwriters to make sure that instead of 30 minutes that it takes for our Wormhole proof to be generated, it only takes around 12 to 20 seconds. It's slightly slower in the UI because we're not pulling that fast. But in real time, if you go and watch your wallet, it will happen in 12 to 20 seconds.
Covalent is solving the long-term data availability problem, where a lot of the data availability providers today in the modular space, when you post data to them, they actually only hold that data for about 12 to 16 days. And then it's basically, it can go into an archive node, or oftentimes it's just kind of put away into the abyss. And what Covalent's trying to do is build this long-term data availability solution, which can plug into some of these modular data availability providers and provide this longer-term perpetual data solution. So what we try to think of this as is when you post transaction data onto Celestio or Veil or any of these modular DA solutions, or even Ethereum, Covalent is able to provide a long-term data storage and data availability platform for that data after the time period. Blockchains are billboards, not databases, and we need these providers in the space to be able to kind of hold on to the long-term data that is provided from these providers and these blockchain state. This is where Covalent comes in. They just had a nice rebrand. Check them out on Twitter as well as their website. Thank you for being here. Hope you enjoy the rest of the show. Mantle is a layer 2 blockchain with one of the biggest on-chain treasuries in all of crypto, and they have a 100-day campaign called Metamorphosis live now. What this is it is a campaign for their liquid staked ETH token, METH, as well as their upcoming liquid restaking token, CMETH, where you can utilize this token on the Mantle network in a variety of different apps, some of your favorite restaking protocols and DeFi protocols, and earn yields in the form of powder, which will eventually be turning into a governance token. Mantle's been around for a while. We like them because they use their own form of EigenDA. They have a good ecosystem and they're growing. So check out this 100-day Metamorphosis campaign, and hope you guys enjoy the rest of this video.
There's a really infinite design space when considering these logic dependent swaps that you talk about. It was Fig from the Squid bridge aggregator who kind of opened my eyes to this, which if we think about all of these different possibilities for payments, the one use case that I think that really resonated was let's say I want to take a trip. And on this trip, I'm going to book a flight, a hotel, and I'm going to see a concert on this trip. And so I only want to book the flight and the hotel if I'm able to get the concert tickets. And let's say there's a 2-day concert. One of them's Friday night, one of them's Saturday night. If I'm only able to get the Friday night, I want my flight on Friday, right? Not on Saturday. And if I get the Saturday, then I want to switch my flight, and I only want to do that dependent on the concert ticket that I get. And so this logic dependent swaps are it's very it has really far reaching implications, because there's lots of different use cases here that could play out. depending on, not just financial use cases for DeFi, but also use cases that stretch beyond like just in general, like products, services that are dependent on one or another. Thinking like just getting inspired here, like thinking about the different like AI and machine learning use cases too. If I want to design a certain use case and I want to tell my AI to go design a script, certain plugins might be available and I might have to use a use case dependent on certain plugins and not on other plugins. And so I think the implications of these logic dependent swaps are really far reaching and really just really, really cool to see. So I'm pretty inspired by the infrastructure that you guys have built to support these logic dependent swaps, purchases, and beyond.
Yeah, I'm very happy to hear that. I'm also very excited to see what people are going to do with it. Since, I can only imagine so many things. But I really hope that people take it and really do something with it. Because cross-chain has kind of been missing this kind of dependency. I want to only do this if this also is true. And yeah, we've seen some parts of it with shared sequencing. But shared sequencing is currently like much further out, and Catalyst logic dependent swap is something you can access right now. If you go to the mainnet deployment, it has it open. You can just go and do a swap, and you can set this dependency. Like you can even do this where you do a cross-chain swap, and you're like, I don't think I want to do this anymore. Submit a transaction on the destination side, say I regret it, and then it will fail. And that's just one of the very simple things you can do. And as you said, there's so many things that you can do in the future with it that I'm very excited to see.
Yeah, me too. And I think it brings a kind of a question to my mind with regards to where Catalyst can really do these swaps and these cross-chain interactions in kind of outside of just the Optimism OP stack chains. And as you guys start to scale more and more chains, I'm curious, like what kind of dev implementations are required there, and like what is the obstacle for Catalyst to be on or to not be on, all of the rollups and all of the app chains by the end of the year? You guys could be on 100 chains. Like what would stop that from happening on your end?
So there's currently two things that are like problems with scaling. One is just how do we do it? Like how do we get all of the RPCs? How do we spin up all of the servers? How do we structure it so we're not overloading ourselves? There's like an on-chain component, but there's also an off-chain component. And I think the off-chain component is just as important as the on-chain component. And we're working very, very, very hard to get the off-chain component such that we can just add a new chain in a 10-minute span. Now it's on the UI. I think we need to work towards like permissionless UIs, permissionless cross-chain APIs for the UI and stuff like that, to make sure that these, scaling just happens almost exponentially. And I think we'll get there. I think this is one of the easier problems as well. I think the on-chain part is the difficult one. And it's just because we haven't paid as much attention to it yet. And once we get that, it will just go off. The other one is more of the on-chain and what is required. We still need a messaging protocol, of course. Currently, we only have two messaging protocols integrated. That's Wormhole and Polymer. Though I can reveal that we do have two more in the works, and we are in talk with another one. So hopefully, in half a year, we have 5 integrated. That will be my very ideal point. So right now we are limited to what Wormhole can provide because Polymer is still on testnet. But once we have the other ones, you can quickly imagine that the number of chains that we can support just almost scales exponentially, especially because a lot of these messaging protocols try to be specifically good for a certain ecosystem. So each of these ecosystems, as long as it's just covered by one of them and there's kind of a bridge out, now it's connected to the rest of the Catalyst network. So I think those two are the main biggest pain points. But generally, anyone can deploy Catalyst. Our code is completely open. You can actually go to our repository right now and deploy it to all of the chains. We don't even need to verify it. It will just go up on the correct addresses. We use grade 2 a lot. So you can just go and do it, and then it'll be there and waiting for us to connect it to the UI.
Yeah, so if you can get the additional interoperability partners, then this can scale, and it can just continue to scale with them. I think Rob has a question, and then I'd like to kind of zoom out of Catalyst and talk a bit more about your thesis for where this space is going to be heading next.
Yeah, I am curious, like, so Uniswap was able to solve this scaling issue thing by giving permissionless optionality to the users to come in, paste the token address, and add liquidity yourselves. With more and more permissionless tooling and projects popping up, Hyperlane with permissionless interoperability, Lava Network with permissionless RPCs, do you think there's an option at, like, how do you see the integration of some of these permissionless partners to really open up and scale infinitely and allow anyone to come in and operate and scale on your behalf?
Yeah, so this is something we're working very hard on. There's a lot of issue with it. It's a trust issue, because you could easily just have an interface where you provide an RPC and we'll connect to that RPC and we will index it. But who is to say that that RPC is actually representative of the true state? How do we verify that an RPC belongs to that specific chain? Is not just saying it is and trying to make users sign fraudulent messages. And all of these trust assumptions that are kind of through an intermediate partner that we need to verify, that is making this harder. I think the solution to this is kind of what I've talked about, trying to scale the API that we have so that it's permissionless, so anyone can run an API, anyone can run the UI, and then these UIs you can now add chains. Then you can just make a PI into our repository and we can merge it, and now that chain is also on our interface. I think that is currently the most feasible approach, but I'm really looking forward to someone figuring out a solution to this problem. We can tackle the liquidity problem, permissionless deployment of the protocol, permissionless pool creation, permissionless cross-chain liquidity, and permissionless connecting the liquidity to the Catalyst network. And as you also talked about, Hyperlane figuring out the permissionless interoperability, Lava figuring out the permissionless RPC. You just need to figure out someone just needs to figure out how to do the permissionless chain verification. I don't want to say that someone, as in we can't do it. It's just that our short-term roadmap is so tightly fixed that I'm unsure if it's going to be us. But I really hope that's a solution that people are working on, so that we can get the whole stack independent or permissionless. That's my best answer. I'm sorry I can give a more fulfilling answer, but it's a very hard problem to tackle. Also because all of the infrastructure, servers that need to be run to index and so forth, that needs to be managing this.
Cartesia is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesia enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesia.io, that's cartesia.io, to learn more about building your own app chain today.
Yeah, that's the ideal end state. But yeah, it kind of helps to have a team helping around, right? And that's kind of what crypto is about. Zooming out a bit from Catalyst here, we talked a lot about kind of the technicals about how it works under the hood and where we go from here. I'm more so generally curious now about your thesis for where this kind of multi-chain, cross-chain landscape goes from here. We're starting to see a lot of chain abstraction projects pop up and kind of build out that tooling, and just generally the advent of a lot more chains. I'm curious on what is your thesis of the way the cross-chain landscape evolves over the next year or so, and kind of what major changes or even minor changes or thoughts, that you can share with us for where you see this landscape headed.
I think we are on a road right now. I think it's pretty clear that we're going towards more chains. There's a lot of chains as a service. There's a lot of rollups as a service. we see a lot of chains popping up specific for application. But we also see a lot of chains coming up with this kind of more like general application chains. So I think we're going into a future where there's a lot more chains. There's going to be a lot of applications having their own chain if they're built on a rollup as a service or a chain as a service stack, or if it's even their own specific chain. I think that will happen. There's also going to be a lot more application blockchains, essentially kind of like Base or Optimism, simply because I think the power that some of the businesses on these chains have is very significant. You can see how Coinbase is kind of integrating Base directly into their wallet and like trying to make on-chain, off-chain, which I think is very exciting. But you can also see like a lot of applications just seeing the feature of having their own chain, like providing cheap services to users where they don't have to worry about, the ETH gas spiking on a bad day and stuff like that. And I think that is kind of inevitable. Ethereum has a fixed size, and they're also going towards this sharding future, which is kind of more like a roll-up future. So it's even inevitable from that. And even if you look at Solana, which is like this super fast chain, as you branded like that, it also has bottlenecks at some points and kind of need roll-ups to further scale. So I think like many chains, that is the future. It's kind of not even like a question if it is the future. It's kind of just what we see. And I think some of this fragmentation that comes from it is like inherent in it, and we need to build more cross-chain native applications. That includes Catalyst, which can do this, asynchronous liquidity in different chains. But we also need other cross-chain solutions. We need cross-chain lending service. We need optimizations, using Wire and similar on Ethereum. Maybe we also need those cross-chain. And there's also, other services that are also relevant to do cross-chain. Gaming, how does gaming work cross-chain? Or do we just have games on a single chain? And yeah, I think that it is the future, and the general way we see applications moving kind of has to be. From what I read, AVV4, I think it is also moving in this where you can deposit on one chain, withdraw on another, or like borrow on another. And there's also a lot of other lending as service competitors coming up to Aave that can do similar. So I think it's also in their thesis, it's also that future that we're moving in.
Yeah, the Aave chain announcement was interesting, and I think that we're generally aligned on quite a bit of your thesis here on the roll up, and have been seeing this play out for the last 6-8 months, and think it'll continue to kind of play out. So kind of coming to a wrap up here, Alexander, thank you for coming on and sharing insights about Catalyst, your journey through being a developer and putting a vision together to see this future of cross-chain and a multi-chain crypto world. And I think it's only going to accelerate from here. And so excited to see Catalyst kind of push forward and be one of the leading players in helping to bring this all together. So thanks again for coming on.
Yeah, thanks very much for having me and asking very good questions.
Any alpha on the next math paper?
I don't know if we're going to be publishing a paper in the near future. We do have a very exciting protocol coming up, but I cannot reveal much. I'm very sorry about that.
No worries. Cool, man.